So today's lesson is a continuation of section 1.2. And we're going to call it Find a Difference Quotient of a function. And we are going to look at the function f of x equals 3x squared minus 4x minus 5. And so the value of f of x, or the value of the function, it's going to depend what we substitute for x. So occasionally we can substitute a numerical value. So if I wanted to find f of 4, say, I would erase and replace the x with a 4 in parentheses. And then I would evaluate the function in order of operations order. So being careful to complete exponents first, then multiplication and division, then addition and subtraction. So your calculators can do this, but only if you put it in correctly using the proper parentheses. So 48 minus 16 is 32, minus 5 is 27. So there I used parentheses carefully when I had a positive value. I absolutely need to be on my toes with my parentheses when I'm substituting in a negative value. So we'll show that to be worked out here. I'm going to do negative 3 squared and get 9. Minus 4 times minus 3. In my head I'm working it out already, but I'm trying to stress using your parentheses and following the order of operations. So I wanted to do this multiplication first, then this one. Now I can do my addition and subtraction from left to right. 27 plus 12 minus 5 equals 34. So that's what happens when you substitute a numerical value. But you can also substitute expressions. So I'm going to show what f of a looks like, and then right over here I'm going to show what f of 2a minus 3 looks like. So I'm going to substitute those in, and instead of getting a numerical value, my final answer will be an expression. So if I plug an a in, erase and replace the x with an a, 3 times a squared minus 4 times a minus 5. Then I work out the algebra, and I kind of end up with the original function just with an a instead of an x. But things get kind of interesting when I'm substituting in an algebraic expression. And I know I've mentioned it probably twice already, but you cannot be too careful with showing your substitution using parentheses. So I want to make sure that I stress that. And then the other piece of this is that if you were an awesome Algebra 2 student and you're super excellent at double distribution, some of you can do this in your head. The rest of you had probably better expand it out, or else my concern is that you are going to lose some of your terms. Okay, so when I'm doing double distribution, I need to remember that I get 4 terms here. 4a squared minus 6a minus 6a plus 9. I'll go ahead and distribute that, and now I can distribute over here as well. I'm going to combine these like terms. 12a squared minus 6 is minus 12, so 3 times minus 12 is negative 36a. 3 times 9 is 27. And then I still have some like terms to combine. So that's my only a squared. And then minus 36a minus 8a, so negative 36 minus 8 is negative 44. Plus 27 plus 12, that's 39, minus 5, that's plus 34. So probably could factor out a GCF there or simplify it in some other way, but for now, expressing in standard form, which is descending order of the variable, is good enough for me. So that's going to be what we're getting into here when we have expressions that we're substituting in. So next I'd like to substitute an expression that contains two variables. So I'm going to substitute and do f of x plus h. And I'm going to plug in 3. So let me just write the original function here. F of x equals 3x squared minus 4x minus 5. So now I'm putting in 3 times x plus h squared minus 4x plus h minus 5. And I'm going to expand this out. I'm going to distribute, double distribute. And I get 3 times x squared plus 2xh plus h squared minus 4x minus 4h minus 5. And then I'm going to combine any like terms that I happen to come up with. So actually it looks like I don't have any like terms there. So I can just leave it at this point just like this. And the last one I want to do is f of 5 plus h. And if you can, pause the video, try this one on your own first, and then just check your answer with me. So I'm going to substitute 3 times 5 plus h squared plus, and that's a minus 4x. So negative 4 times 5 plus h minus 5. So I'm going to do 5 plus h squared by expanding it out. 5 times 5 is 25 plus 5h plus 5h plus h squared minus 20 minus 4h minus 5. 75 plus 30h plus 3h squared minus 20 minus 4h minus 5. Alright, so it's time to combine like terms in descending order of the variable. 3h squared. Now I'm going to combine my h's. Positive 30 minus 4. And now my numerical value, 75 minus 25 is 50. So now that we're clear on all of those, hopefully you're good at those. You'll have a chance to practice if you're not. So the difference quotient, we call it that because those are the two operations that it contains, subtraction and division. Here's 4 ways that the difference quotient is often demonstrated. So we would want to find an f of x plus h and then subtract out f of x and divide everything by h. Sometimes they use an a, f of a plus h minus f of a over h. Sometimes we're given a value for h, like 5, or given a value for x, and sometimes we're just using a value called delta, which is some unknown little tiny increment that we're making to our function, and then we're dividing through by delta x. So these are just different notations for the difference quotient, and our goal whenever we do one of these is we want our h or our delta x in the denominator to cancel out, and you'll see what I mean in just a moment. So let's take our original example and let's do a difference quotient. So we're going to take f of x plus h minus f of x divided by h. We're going to use our original f of x equals 3x squared minus 4x minus 5. So first thing I'm going to do is substitute in an x plus h. 3 times x plus h squared minus 4x plus h minus 5. Then, so that's the f of x plus h. Then I'm going to subtract out f of x, which is just the original. 3. Let me see if I can zoom out here. 3x squared minus 4x minus 5. All of that divided by h. So we've got just a really big algebra problem here. So I've already worked this out one time, but let me go ahead and just rework it. 3 times x plus h squared minus 4x minus 4h minus 5. So that's all the first part, minus 3x squared minus 4x minus 5. So ideally you guys will get to where you don't have to write this. You can just simply know that your result is going to be x squared plus 2xh plus h squared. So notice I'm just working out my numerator right now. I know all of this is going to eventually be over in h. So let me go ahead and draw that there just so I don't leave it off. So let me distribute here. 3x squared plus 6xh plus 3h squared minus 12x minus 12h minus 15. And then I'm going to distribute this minus sign. Minus 3x squared plus 4x let's see, look here. I said careful use of parentheses is essential, and here I made a mistake. This 3 times x plus h squared, so that 3 was just supposed to be for these 3 items, not the whole expression. Okay, so let me go back and fix that. This is still, instead of minus 12, that's still a minus 4, a minus 4, and a minus 5. Minus 4x minus 4h minus 5. So now that's all distributed correctly. Here I'm distributing my minus sign. Minus 5 is plus 5. Okay, so remember I said that the whole point is to get your delta x's or some of your h's to cancel out. So that's what I'm hoping is going to happen here when I do my combining like terms. So here I've got a 3x squared and a minus 3x squared. And here I've got minus 4x plus 4x minus 5 plus 5. So now I get 6xh plus 3h squared minus 4h, and that's it, all that over h. So now I'm going to factor out an h using a GCF, so I get 6x plus 3h minus 4. So a lot of my h's do cancel out. So my final answer here is 6x plus 3h minus 4. And that's the correct answer. So it's not very satisfying. You're going to get some expressions with some variables in them. But that's why it's so important that you can be accurate with your parentheses and your algebra. So let's try another example, and let's use one of the other ones. Let's do f of a plus h minus f of a all over h. And to do this one, I'm going to use some of the work that I used on my last page. So over here where I have, well, did I do a plus h? So I didn't, but it's going to be the same as x plus h. And then f of a is down here, so I'm going to go ahead and substitute f of a plus h. I've got the same as what I had in the step before, except using an x, I end up with an a. So I'm going to get 6a plus 3h minus 4. That's my final answer there. In the next example, I want to do f of 5 plus h minus f of 5 all over h. And so I'm going to use my previous notes. So f of 5 plus h, that is 3h squared plus 26h plus 50. Then f of 5, well, I didn't work that one out, so minus f of 5, so I'm going to go 3 times 5 squared minus 4 times 5 minus 5, all this stuff over h. So let's see how that all works out. So over here I'm just going to have to work out my math and get a numerical answer. 3 times 5 squared, that's 75, minus 20 is 55, minus 5 is 50. Okay, so I've got 3h squared plus 26h plus 50 minus 50 all over h. So these guys cancel out and equal 0. So 3h squared plus 26h over h. So I'm going to factor out an h. And I get h equals 0, or h equals negative 26 thirds. Oh, sorry. I was treating that as a factoring problem, and I don't have it equal to anything, so all I can do is cancel the h's here. So I am just left with 3h plus 26. Sorry, my apologies. Alright, so let's take a look at some other more complicated functions besides just that little quadratic there. So we're going to start with a radical function. So this example, our function f of x is the square root of x. And I want to do a difference quotient. So I'm going to set it up like this. I'm going to do f of x plus h minus f of x all over h. And I'm going to substitute in. So radical x plus h minus radical x all over h. And I see that I want to rationalize the numerator. Okay, so the question that I want to be able to explain to you guys is, why do I need to rationalize the numerator? Normally we're rationalizing a denominator. So I want to try and pull this h out from underneath the radical so that eventually there'll be something to divide through by this h. So recall that whenever you want to rationalize anything or pull things out of the radicals, you multiply by the conjugate. So that's just going to be the same two terms, except instead of a minus, I'm going to do the opposite sign. And when I'm multiplying by a conjugate, I have to multiply by the top and the bottom. So let me go ahead and multiply these things together. Square root of x plus h times the square root of x plus h is simply x plus h. And then the square root of x times the square root of x plus h and minus the square root of x times x plus h. Those two terms are going to cancel each other out. That's what always happens in a conjugate. And then negative square root of x plus square root of x, that's going to equal minus x. And then in my denominator, that's where I kind of have like a bunch of messy stuff now. So I've just got h and the square root of x plus h plus square root of x. So what's the point of all this? Well, you can see that x plus h minus x, we end up with simply h on the top. And then we have h kind of out by itself on the bottom. So these h's actually cancel. So that was my goal. Let me come down here for my final answer. So whenever h divided by h equals 1, this h went away. So now I have square root of x plus h plus square root of x. And this is my final answer to my difference quotient. I'm going to go back and do a simpler problem that just is a little more algebraic. So this in your book is example 10. So I'm going to number that the same so that you can go back and find it. It's on page 23. So if I have a simple function, f of x equals x squared minus 4x plus 7, and I want to find the difference quotient. So you're going to start that out by using your difference quotient notation. So that tells you to do f of x plus h minus f of x all divided by h, and then you're going to substitute that in. So f of x plus h equals x plus h squared minus 4 times x plus h plus 7. So all of that minus your original f of x, which is x squared minus 4x plus 7. And then all of that will be divided by h. So now I am going through and foiling and distributing, and in general using algebra and simplifying. So here we've got x plus h squared that's a perfect square trinomial. So x squared plus 2xh plus h squared minus 4x minus 4h plus 7. And then all of that minus x squared minus times minus 4x is plus 4x minus 7. And all of that is over h, and now I'm ready to combine like terms. So I have x squared minus x squared minus 4x and plus 4x plus 7 and minus 7. So I get 2xh plus h squared minus 4h over h. And I'll factor out an h. And so here we go. I get 2x plus h minus 4, and that is my difference quotient. And I just need to make a note here, because h is on the bottom, the only rule for my domain is h cannot equal 0, because I never want to divide by 0. So in the next video I'm going to show you a few more complicated examples, and then you'll have everything that you need to be able to work out your practice problems.